And if the nucleolus is in the core, which I would suggest, I mean, you can look at the definition to argue that it is. That means that every coalition receives at least its worth. So this is at least as big as this is at least as big as this. And if an imputation is in the core, that's the case for every coalition, so that every possible excess will be non-positive. So that means that for this particular two-player game, there will be three possible coalitions. The excesses will always be such that the excess for the grand coalition will occur to the left, in the leftmost position under theta. And then these might be in this order, or they might be in the opposite order. I'm not sure. Okay? So depending upon the imputation x in the core, either this will lie to the left of this, or this will lie to the left of this. Okay? So this is just sort of a general. This is generally the case for any x in the core of V. Okay? I claim that in order to tamp this down as far as possible, in order to lexicographically minimize this vector of ordered excesses, this is going to be equal to this. How do I know that that's the case? Well, let's suppose, for example, here, this is 0 and this is -1, right? These are not equal. Well, I claim that then it's possible to lower this and raise this, and hence lower theta in the lexicographic ordering. Right? If this comes down and this goes up, but they stay in the same position so it doesn't jump over this. I mean, if this goes down too far, this will jump over it. You'll have to rearrange it. For example, if this goes all the way down to -1, this will go up to 0, and then they'll switch places in in theta. But at least a little bit, we can lower this, and that's going to have the effect of raising this, because we're going to shift payoff from player, in this case, we're going to shift this. We're going to shift payoff from player 1 to player 2. And when we do that, this will go up a little bit, this will go down a little bit, and we'll be able to lower this in the lexicographic ordering. So if we're at the bottom, these last two must be equal, as they are here. Okay? So I claim, again, that at the lexicographic minimum, this must be equal to this. And it doesn't matter which order they appear, because they're equal. Okay, so let me sort of prove this for a moment. Let's suppose that this is equal to this. And because this is an imputation, we know that x1 plus x2 is equal to v12, right? And so let me rearrange this. This means that x1, bringing this to the other side and bringing both of these over here, we could rewrite or solve this equation for x1. x1 is equal to v of 1, so bringing x1 over to here, x1 is equal to v of 1 minus v of 2 plus x2. That's rearranging this equation, or solving this equation for x1, okay? And from this equation, well, actually, I guess what did I do? Yes, so now what I want to do is solve this equation for x2. So x2 is equal to v of 1, 2 minus x1, and I'm going to substitute that here. So that's x1 is equal to v of 1 minus v of 2 plus x2, which is equal to v of 1 minus v of 2 plus, this is v of 1, 2 minus x1. So I have x1 is equal to v of 1 minus v of 2 plus v of 1, 2 minus x1. I'm going to bring this over to the other side, add x1 to both sides. I would get 2x1 is equal to v of 1 minus v of 2 plus v of 1, 2, and then divide both sides by 2. I get x1 is equal to v of 1 minus v of 2 plus v of 1, 2 over 2. Okay? If I add and subtract v of 1 over 2, then that means that x1 is equal to v of 1 plus b of 1, 2 minus b of 1 minus b of 2 over 2. That's the standard solution. Player 1 at the nucleolus will get its worth plus half of the surplus. This is exactly the same as we discussed before when we discussed the standard solution to two-player games. Okay? So the nucleolus, this lexicographic minimizer of the vector of ordered excesses, in the event the core is non-empty, will always assign to each of the players this standard solution. They get their worth plus half of the surplus. Okay? Okay. Let me just finish today by noting three properties of the nucleolus. First of all, every game has a nucleolus. So when the core is non-empty, the nucleolus will be in the core, and that's easy to see too, because if the core is non-empty, it means that it's possible for all of those to be negative or non-positive. So that when you're tamping this down, when you're minimizing this in the lexicographic ordering, that means that indeed these will all be negative or non-positive. You couldn't have a positive one of these because it would jump out and it would rise up in the lexicographic ordering. So every game has a nucleolus. The nucleolus is unique. There's always a unique payoff vector that corresponds to this lexicographic minimizer. And when the core is non-empty, the nucleolus is in the core. Just in terms of pictures, let me suggest, I'm not going to make this precise, but let me just suggest that this was not a coincidence, that in some sense, the nucleolus picks sort of the center of the core. So you can imagine this, this is for a two-player game. This is the core, and the nucleolus picks the middle of that. For a three-player game, as we saw here, I didn't draw out the whole core, but the core is going to be some subset of this surface, the set of vectors x1, x2, x3, such that x1 plus x2 plus x3 is equal to 5. That's a simplex. The core is going to be, if it's not empty, is going to be some subset of this. There are going to be some imputations that the components add up to 5, and that every coalition gets at least what it can achieve on its own. And the nucleolus is going to, in some sense, pick the middle of that core, the center of that core. Okay? And that seems relatively reasonable because the core can, rather extreme points can be in the core, and a sort of natural focus is in the middle that sort of divides the benefit evenly, so to speak. Yes? Okay. Any questions? And I think that's all the time we have for today. So we'll meet again on Monday. I'm going to assign some problems later today, and I'll post those on Blackboard, and I'll send you an email when those are up. And those will be due, I'm not sure yet, either on Monday or on Wednesday, depending upon how many I include. Okay? Okay, then I'm going to stop sharing. I'm going to log out, and I'll see you again on Monday.